talked about limits this year so far? I say yes, okay, in different ways. But a limit for an infinite sequence is sometimes a sequence comes closer and closer and closer to a certain number and it doesn't reach it. Does that make sense? Then it would be a limit, okay? The only way that a sequence would have a limit is if it converges, because if it blows up or diverges, it's going to approach infinity. We don't call that a fixed number. Okay, so here's a sub n, and let's let a sub n be a sequence of numbers. Okay. Two things could happen. If the limit of a sub n, and what I mean by that is if I start putting in more and more terms means n's going to go to infinity. If I keep finding more and more and more terms and it approaches a fixed value, L, I should have written it in 2 lines. So if the limit of a sub n, written this way, approaches a fixed value L, then it converges. And its limit is L. If the limit as n goes to infinity, a sub n, is infinite or non-existent, then it diverges. Alright, you guys ready to take a look at some, or are you writing still? I'll let you write still. Okay, so we are going to determine... What's that? Are you still writing?
No.
Oh. We're going to determine whether the sequence converges or diverges. Alright, I'm going to take one of those ones from the opener, okay? The first one, not the opener, sorry, the 1 over 1, 1 over 2, 1 over 3. Okay, and by the way, these are going for infinity because we're approaching infinity. What's going to happen, okay, as these get bigger, as n gets bigger? The number, yeah, when you have a large number on the bottom of a 1, doesn't that drive that fraction, okay? Like, let's put in a really big number. 1 over 500,000. Sure, a million. What is this going to get closer to Good. Okay? So this converges because as these go up and up and up, these fractions approach 0. And so I would say for this, that this limit as x goes to infinity of 1 over n equals 0. Okay, let's look at another one. What if I did kind of something with fractions, okay? Let's see if you can figure out this pattern. 2 over 1, 3 over 2, 4 over 3, 5 over 4, dot, 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 dot. Okay. Can you guys figure out the pattern first of all? Good, Carmen. She's listing some more. Okay. 6 over 5, then 7 over 6. In general, how would you describe that? If I did it this way. If the top number was, if the bottom number was n, what's the top number? Good. Okay. I think it's helpful to think of this in general, okay? Now, because at first you might think, nope, these are getting bigger, doesn't converge, okay? Does this one converge? And if so, what do you think it converges to? Good, Bobby. All right, now, you could split it up actually, okay? If I was doing this, if I said the limit as n goes to infinity, if I divided both of these by 1, let's do both of these by n. Isn't that what that means on the bottom? I would have n over n plus 1 over n. Agreed? What's n divided by n? 1. And didn't we already decide when I put a really large number into this, what does this go to? 0. So really what this is saying is split it up. This is 1 plus 0, and he's right. This does have a limit, and its limit would be 1. Okay, let's go through, let me just show you a couple more that don't have one, like when does it diverge, so you can see what that looks like. I'm going to show you one that gets really, really large, and then one that's kind of weird. You might think, how would I find the limit of that? All right, so the third one I'm going to give you is one of the ones I listed at the beginning as well. 2, 4, 6, no, I did that last time too. 2, 4, 8, 16, 32, 64, and we know in general that this is 2 to the nth. Okay? 2 to the first, 2 to the second, and so on. What's going to happen as n gets really, really large? This is going to approach infinity, correct? You would say the limit as n goes to infinity of 2 to the n, isn't that infinity? Really big number? Earlier I said if a limit approaches infinity or doesn't exist, what's the word we say to describe it? Starts with a D. Yep. So A and B were converging. They converged and they had a limit. C diverges. And then here's one that also doesn't have a limit. And I'll tell you why. Okay, what's going on there? It's being multiplied by -1. Couldn't I actually describe it as -1 to the nth power? Because -1 to the first is -1, but when I square it, it becomes positive and so on. Okay, so if I set this, hey, what's the limit as n goes to infinity? Okay, it's not infinity, right? But what is it either going to be? It's going to go -1, +1, -1, +1. If you were to graph those, It's going to flip, negative 1, positive. Is it approaching one fixed number? No. We would say this just does not exist. It does not exist because it is actually going back and forth between two numbers, negative 1 and 1. And that was the other thing I listed for divergence. If the limit does not exist, we would say this divergent. What's that? Oh yeah, actually we watched that in calculus because we wanted to figure out if we could figure out the and we could, yeah. It was calculus. No, it wasn't this because you had to do it involved calculus, but we did look at it. It was funny. We actually did it.